Hi students, today we are going to learn the topic acceleration due to gravity. First of all, what is meant by acceleration? In the previous chapter, force and laws of motion, we have studied second law of motion, where force is equal to mass into acceleration, is it not? And before that, in the chapter motion, we have studied acceleration is defined as the rate of change of velocity of a body. So whenever the velocity of the body changes either in magnitude or in direction or both magnitude and direction, then it is said to have an acceleration. Okay, now let us take this larger sphere is our earth and its mass is capital M. Now I will take a small mass small m above the surface of the earth. So at a point A, and I will drop the mass small m freely. So what will happen when I drop the mass? It will come towards the earth because of gravitational force. So this only is called as a free fall. So when the body is falling only under the gravitation of the earth is said to have a free fall. So it will cross another point B below A, and then it will cross another point C below A and B, and finally it touches the earth at a point D. Let us assume. So what is going to happen? Initially when the stone was at rest, its initial velocity was 0. Is it not? Its initial velocity at A, the initial velocity u must be equal to 0. Then I drop it freely. So it falls freely under the influence of the gravitational force, and as it crosses the points A, B, C, D and all, what will happen to its velocity? It will continuously increase in its velocity, and finally it will touch the surface of the earth at a point D with a very high velocity. That is called the final velocity. So there is an increase in the magnitude of the velocity. So here the direction does not change. You can see that A to D is the same straight line. So here the magnitude of velocity changes. Okay. And what about the direction of velocity? Direction of velocity remains the same. So direction of velocity remains same. Anyhow, there is a change in velocity. So due to the change in the magnitude of the velocity, the falling body gains an acceleration. So there is an acceleration. So this acceleration is gained. Acceleration is gained due to which force gained by the body? Acceleration is gained by the body. Due to which force acting on it? Due to gravitational force exerted by the earth. So due to gravitational force exerted by the earth. So this acceleration gained by the body due to the gravitational force exerted by the earth only is called as what? Acceleration due to gravity, and it is denoted by the symbol small g. Okay. Now finally where this small mass has reached is at the point D, after which it is not penetrating through the surface of the earth because the earth is a solid sphere. Suppose if there is a tunnel on the surface of the earth, what should have happened to this mass? Imagine if there is a tunnel here up to the center of the earth, the body will continue. So all the bodies above the surface of the earth and whichever is on the surface of the earth are under a constant acceleration called as acceleration due to gravity. Even now I am standing on this classroom floor. You are also sitting on the seats, chairs, desks. You are also being constantly accelerated towards the center of the earth. But why you are not moving towards the center? Because the earth is a closed solid sphere. Suppose if it is opened below our feet, means we will fall down up to the center of the earth due to this acceleration. Okay. Now Let us assume the body has reached the point D. After reaching the point D, this body of mass small m will be at rest, and the distance from the center of the earth to the center of this small mass m is nearly equal to the radius r of the earth. So let capital M be the mass of the earth and capital R be the radius of the earth. So let capital M equal to mass of the earth, and the mass of the earth is nearly equal to 6 into 10 to the power of 24 kilogram, and capital R be equal to the radius of the earth. So the radius of the earth is 6400 kilometer. So this is equal to 6 into 6.4 we can take, or nearly equal to. So nearly equal to 6 into 10 to the power of so kilometer itself is 10 power 3 meter, and here decimal I have kept, so this is nearly equal to 6 into 10 power 6 kilometer. So exactly means 6.4. Nearly I have taken 6 into 10 power 6 kilometer. Okay. Now, when this small mass is kept on the surface of the earth, it is at a distance of capital R from the center of the earth. So the center of the earth is taken to be O. So what will be the gravitational force? What will be the gravitational force acting on it? The gravitational force Fg is equal to capital G into mass of the earth into mass of the body divided by the distance square, that is equal to R square. Isn't it? So this is from which law? This is from Newton's law of gravitation. So this is from the law of gravitation or universal law of gravitation. Now from Newton's second law of motion, the weight of the body is also equal to the gravitational force. So weight of the body is also equal to the gravitational force. So it must be mass into its acceleration due to gravity. Is it not? So G is the acceleration due to gravity attained by the body on the surface of the earth. So its weight must be equal to the gravitational force acting on it, and that is why it also can be written as equal to what? Mass into acceleration due to gravity. This is from Newton's second law of motion. So the left hand sides of these two equations are one and the same. Therefore I can equate mg is now equal to capital G into mass of earth into mass of the body divided by radius square. Okay. So cancelling the mass m on both sides, I can write G equal to capital G into mass of the earth divided by R square. So this relation is very, very important for us. So any student must remember this is the relation connecting what? Equating small g and capital G. So in the examination, usually a question is being asked. Derive the relation, obtain the relation between small g and capital G. So this is small g equal to capital G into m by R square. So small g is called as acceleration due to gravity. It is normally acceleration only. So its unit is what? Meters per second square. The unit for acceleration. And what is capital G? Capital G is what? Universal gravitational constant. So the value of capital G already we have come to know that it is 6.7 into 10 to the power of minus 11 Newton meter square per kilogram square. So if you substitute the value of capital G, this value, then capital M, this value, and capital R square, this value if you substitute, so this will be equal to what? Now capital G is 6.7 into 10 to the power of minus 11 into mass of the earth is 6 into 10 to the power of 24 kilogram divided by radius square is 6400 or nearly equal to 6 into 10 power 6 the whole square. So this numerical calculation will give you the value nearly equal to 9.8 and the unit is meter per second square. Therefore, G, the value of G is equal to 9.8 meters per second square. Okay, now look at this equation for small g. Here on the right hand side there is a term capital M, that is the mass of the earth, okay, on which the body is falling. There is no small m term. Can you see this equation? There is no small m term because already it has been cancelled. M is cancelled. So what does this indicate? The value of acceleration due to gravity is the same for a smaller mass as well as a greater mass. That means if a mass of 1 kilogram is falling or 10 kilogram is falling in the downward direction, both these masses will have the same acceleration due to gravity because it is a constant for an elephant as well as a cat. Understand? So, the acceleration due to gravity is the same. On the surface of the earth, nearly its value is equal to 9.8 meters per second square. But you keep it in your mind, the value of G is not constant at all points on the surface of the earth. This is the average value. So, the average value at a latitude of 45 degree at sea level, this is 9.8 meters per second square. But when you come to the higher classes, you are going to study that the value of G is maximum at the poles, North Pole and the South Pole, and minimum at the equator. So, the value of G is going to change in terms of the latitude, angle of latitude. And also as you go higher and higher above the surface of the earth, the value of G decreases. Also when you go below the surface of the earth under tunnels and all, the value of G once again is going to decrease. And the variation of small g with respect to height, depth and latitude, now you are not having in your 9th standard syllabus. Anyhow, you get a previous knowledge that the value of G has an average value of 9.8 meter per second square on the surface of the earth. On the surface of the earth itself, it is not constant. It is going to change from one place to another place. So, what is acceleration due to gravity means? How to answer? It is the acceleration gained by a freely falling body under the influence of the gravitational force. And this acceleration due to gravity is due to the change in the magnitude of the velocity and not the direction of the velocity, because the direction is the same for the falling bodies. I hope you must have understood well. Fine.